Good morning, everyone. Today we will talk about cybersecurity in power system. And before going into cybersecurity, we will need, or basically we have to understand why what is smart grid and why the cybersecurity is important in the smart grid. So if I start with what is smart grid, first of all. Uh, okay, so this is our traditional grid that we have generation, then transmission, distribution, and different end users. Right now, just a second. So this is what the our smart grid just a pictorial diagram for that. So we have different generators available with us. So very large generators like nuclear power plants are there. Okay, so those are basically there. Then some local generation is available, some renewable generation is available, and those basically are connected to our grid. Here you can see that like in this yellow one is our grid lines, and the green one is basically telecommunication line. So everything is connected. Then we have the entire grid automation system, where basically there are some intelligent substations are there. Then a smart switch and distribution automation is also there, like on the distribution network side. And then we are able to supply this power to our residential or commercial or industrial loads. Okay, so then like in industrial or commercial loads, we can have this our electric vehicle charging. Okay, and car parking, and also those kind of setup is also there. Large storage systems are also connected in the commercial and industrial setup. Then we have distributed energy management systems. Smart buildings are there where the solars has been connected. Okay, and so this is basically like distributed generation here. Same if we go for the residential one, we have smart home management system. Okay, so and then everything is connected by like in home through Wi-Fi. It is has been connected, and some display units are there where um, like how much power we are consuming, and like to control all the devices in the residential like houses. It is there, and we have a small energy storage as well in the residential buildings. So what has been changed basically? So we have some smart meters. Generally, we call it AMI, Advanced Metering Infrastructure, and by AMI, the entire like loads, whether it is residential, commercial, or industrial, they are also connected to the our telecommunication system of the entire grid. Okay, so via this, like smart meters are here, smart meters are like for the generation as well, and all the entire controlling of this like transmission and distribution network is basically through remote controls. And so the entire I would say the entire grid is like having a lot of meters connected in it, so that we are able to measure each and every aspects of the system. And once and those datas are basically over communication network or telecommunication network are basically sent to the control rooms. And in the control rooms, the system operator has the entire control over the entire system. And by looking at this data, lot of algorithms are going on, and we perform everything in our control room. Okay, so condition monitoring, wide area monitoring, remote control is feasible. Then scheduling, if we want to do schedule the generators and the loads, everything is on the communication network. So this is from the traditional one we have transformed into the smart grid. And if we look at the features, why we have moved to the smart grid is the efficiency is improved because we are able to look, control and observe each and every aspect of the system in a single room. So the objectives are basically to improve efficiency, increase reliability, then enhance the customer engagement as well. So with the help of smart meters, we can go for time of use pricing. Like at the different time of the peak prices can be shown to the consumers, and on the how home display units. Okay, and they are able to schedule their loads. So those things are possible. Let's say there are some loads which are constant and we cannot delay or defer them, but there are many loads in the homes as well which can be deferred. And if real time prices are being basically provided to the consumers, they will usually they will respond to those, and they will change our their consumption pattern. So we can do demand response, shift the peak from to the off peak hours. uh, this system can support the renewable, and by support the renewable means not only the big renewable generation plants or the farms. We can basically incorporate the distributed generation. Those are either connected on at our homes, or like big smart buildings. A lot of power is connected, like in MNIT. Almost every building has a rooftop solar. So basically we can support the renewable energy to the end users as well. Okay, so we had electrical infrastructure where generators are there, and some control room, then transmission and distribution, and to the our consumers. So with intelligent infrastructure, lot of communication devices are basically connected in between, and just to control it better. So we have the existing electrical infrastructure power grid, and then lot of ICT, intelligent communication and devices. So lot of communication infrastructure is also there, and this makes a two-way flow of electricity and information. So that information and electricity both are not from generators to loads. Even loads are also supplying to the grid. So this is a smart grid, like power grid with lot of ICT devices, so that we are basically able to, and with these ICT devices we are able to control the entire system. And usually these devices are basically, we consider them, those devices makes the system smart. Okay, so what is smart grid digitalization? So, smart grid digitalization refers to the integration of digital technologies into our traditional electrical grid, and the objectives are basically, as we discussed, that to improve efficiency, okay, reliability, and sustainability. So this is we can give a very fundamental definition. There are many other definitions as well, but and it's up to what degree of smartness we are looking into the system. Okay, so what are fundamental concept for this? So it- the in smart grid, our grid needs to be smart. Okay, so to make system smart, to basically control the system very smartly and efficiently, um, uh, like just creating a thinking capacity. First of all, is basically the first step is to monitor everything. Okay, so that is basically ability to actively monitor and everything, analyze the entire system, and then once we are able to monitor and analyze, then only we will able to control the entire system. So that is basically the smartness is like ability to monitor, analyze, and control the entire energy flow in the real time. Okay, now to monitor the entire system, first of all we need a lot of sensors. Okay, so different uh, with the help of this ICT, we are able to install you have seen in distribution as well, a lot of smart meters are being installed by this distribution companies under the like RDSS scheme from the government. So this to monitor everything, we need a lot of sensors, but the sensors comes at a cost as well. So it's not that we can put lot of sensors in the system and each and every part can be made observable, but like we can start the first step towards it, and gradually we can make the entire system observable. So first of all we need network sensors. Then once the data it has like these measuring instruments has been placed, then these data needs to be sent to the our control room. So we need a strong communication system. And once a lot of sensors or measurements are being done with the help of these sensors, then a lot of data is there. So we need advanced softwares and computing facility to analyze or do this data analytics on this very big data. Okay, so we need advanced softwares. So now it allows the two-way communication between the utility and consumers. Unlike in traditional power grid, it was only one-way communication from the company to the consumers. Okay, so bidirectional communication is the a game changer. So once it is there, uh, the very one attribute is like out of the smart grid is demand response. Like demand is also responding to the signals and helping the system operator to maintain the grid reliability and sustainability. Okay, so uh, like digitalization is not just automation. Okay, so you have automated based upon certain logic, but uh, it also includes intelligence. Like we have, if we have the real time information, then a lot of like we can process on that information. Okay, and if we just process that information, we are able to make more informed decisions. Okay, so digitalization in smart grid involves converting the analog process and information to digital form, and this includes everything from the sensor reading or meter readings to the entire management of the system. Okay, so by making the digital data, we can apply different sophisticated algorithms and then analyze to optimize the grid operation. So without digitalization, the smart grid would be impossible to realize. So the very first step is monitor. Okay, and for that we need a lot of digitalization of the existing grid, lot of sensors, a lot of communication to secure those data within time without delays, and then lot of algorithms will be needed. Like obviously the data will not be time synchronized. So how we can uh, work on the data which is not timely synchronized. Okay, so that will be the part. Now sustainability, if we talk about, so the digitalization plays a significant role in achieving the energy sustainability goal, and by enabling better integration of the solar, wind, and all the renewable energy sources, it improves the overall energy efficiency of the system, and it reduces the transmission losses because we are able to generate these, like, solars and all at the load end. So we need to transfer less power, so it reduce losses as well. So smart grid contributes to a cleaner and more environmental friendly and responsible energy future. Okay. So what are the components of smart grid digitalization? So we first discussed that, like, smart meters are needed. Okay. So these are basically digital meters that can have two-way communication and provide detailed consumption data of the loads, and this enhance the billing accuracy, demand response capabilities. Like, with the smart meter, the system operator, discoms, or distribution companies or retailers can send the real time prices, and once it is visible that, okay, the prices at this particular hour is higher, they can respond to those prices. So with the help of smart meters, the loads have the demand response capabilities, and also they can manage load in a more better way. Okay, so improved load management as well. Now, different advanced sensors are needed. So to the smart meters, we can say, like, at the consumer end, but to measure the entire system, we need a lot of sensors. Okay, so these sensors should be distributed across the grid to monitor the conditions in real time. So whatever, like, voltages, and what are the currents and what are the power flows in the system, so these needs to be monitored continuously. So the advanced sensors will be needed to basically get this information. This information helps the system operator for the real-time grid monitoring. If any fault is there, fault detection can be done with this help of this, with the help of these devices. And if some predictive maintenance is needed, we can do like plan that as well. To like, so we have discussed about smart meter and advanced sensor. So they are basically measuring devices, and that data needs to be transferred to our data centers or control rooms. So a secure and reliable communication infrastructure is needed to transmit this big data, and also, like, these sensors will communicate with themselves as well, and for that we need a communication network. So this will enable the real-time control, that, okay, and the data exchange and the coordinated grid operation between the different utilities as well. Okay, then once data is measured, it has been communicated, so we are storing a lot of data. So we need then data analytics platforms as well. So we need softwares and algorithms to process and analyze this big great data, and then by analyzing this, we should be able to provide insights, or like insights to, like, how to make the system more optimized, and these data analytics can help the system operator in decision making as well. Okay, so what are the different insights we can get out of it? So the significance of this analytics is to grid optimization of the grid, predictive maintenance, demand forecasting, and if some anomalies are there, we can detect those as well. Okay. Now, what are the key challenges? Okay, so let's talk about it. So first of all, what is cybersecurity? Okay, so cybersecurity is basically about everything available on the communication, and so that communication networks are there. Then, so apart from our existing grid network, we have the entire communication network where we are transmitting that data, we are storing it somewhere, and we are analyzing that data. Okay, so, and everything is happening electronically over the communication network. Okay, so we are storing that data, we are processing on that data, and we also exchanging the data with different stakeholders. So this entire part is our cyber grid. But if it is all on the communication network, they are basically exposed to the cyber threats as well. So we need to build a firewall to protect this data. So here, like, we have to build a firewall to like secure this entire cyber layer with the different threats which are coming from the grid. Okay, so we have to protect it, and it should be well protected, because if you look at the significance, um, you can easily disrupt the entire country by attacking on the cyber layer of the power grid, because without electricity everything will go down. Okay, entire our like all sectors will go down with the electricity sector, so we have to protect it very well. Okay, so this needs to be secured. Okay, so like this cyber network is there, so this is like our cyber layer, and we have to protect it, so that is like security of the cyber layer. Now if we talk about, like, banks, there are a lot of security options basically are. So they have cameras, they have manpower, they have password, they have alert system, and they have secure votes as well. So that part is like, for our traditional like banking infrastructure. But if we want to look at the same thing for our electrical infrastructure, so we have to basically, like for any system, to secure the data. So here it was like in banking, we deposit our, like sometimes money there. So yes, in banking we deposit money, and sometimes our like paperwork as well in the locker. So everything has to be secure. Here, everything in the cyber layer or cyber security point of view, everything is the data. So we have to secure that data. Okay, so it is not in a, like, in an institution. So it's available in open. So we have to encrypt the data, so that even if like, somebody breached the firewall, the data should be encrypted. Some antiviruses has to be, provided, so that if some virus like uh, to should be protected from the antiviruses. Some detection system. So let's say we are making lot of uh, protection schemes, but still if some breach is there, we should have detection system, so that we get the alert, different alerts. uh, if somebody is accessing that data, that should be authenticated. It's not like anybody can access the data, and our user authentication should be very strong and secure. And if some incidents are there happening, we should have a response sheet that, okay, this is how we are going to respond. So proper SOP should be there. Okay, so first thing is, like, does a smart grid require cyber security, and if it is, why? So first of all, why smart grids are vulnerable to cyber attacks? Okay, so let's talk about, like, we have our existing power system, then we have this ICT technology. Okay, and the entire, both the, like, cyber layer and the physical layer, and makes the entire system cyber physical power system. So it's no longer like power system; it's cyber physical power system. So what are the different like what are the evolution? So monitoring and measurement. So by monitoring and taking a lot of measurements, more intelligence at each device is available. So, like, different sensors and meters are there. So those are basically creating more intelligence at like, different parts of the system. Then connectivity. So these devices are connected with each other. They are communicating with each other. So communication between devices is there. Okay, so these are, like, network connectivity is very strong, and like by achieving these two goals, we can go for the automation as well. So we will have different, closed loop process control capabilities, and that leads to the automation of the entire system. Okay, so this is like, this intelligence, communication, and automation represents like it presents security challenges. and cyber attacks are increasing in frequency as well as in sophistication. So yes, we have this system, and it is available, like open in the cyber network. So it this ICT or cyber layer is exposed to cyber attacks. So as we are evolving and like protecting the system with different cyber attacks, the attackers are also evolving, and that's why, like different attacks are more sophisticated, and we are not able to detect them and not able to respond for those attacks as well. And with increasing layer of the like cyber layer, like we are like installing a lot of ICT devices, so we are like creating basically increasing the cyber layer. So that also expose the entire system more, and that will leads to increase in the frequency of the cyber attacks. Okay, so and over time those attacks are basically getting sophisticated, so we need more robust detection techniques and the defense techniques to protect our cyber physical power system. So these ICTs basically are making the system smart, but they are also making the system vulnerable and exposed to the outside. Okay, what are the impacts of cyber attacks? So if we just look at that, like in electricity, if some cyber attacks are there, what can be different impacts? So first is very obvious, power outage. So if we disturb the operation of the power plants, we can disturb the information of the transmission lines, and that leads to power outages. The most immediate and visible impact of the cyber attack. So this is quite obvious, and how we can do is, like we can with the help of like attack on the entire power plant, we can disrupt the operation of the power plant, because the entire power plant is also well connected on the communication network, and if attack is there on the generation side, and then they can basically leads to the like shutdown of a unit, and that may leads to power outage in particular transmission lines. Let's say we can have a false data that certain line is within the limit, but if we can attack the communication network and give a signals to circuit breakers that okay, this line should be tripped, and so that in that case that line will be tripped, and that may leads to the overloading of some other lines, and actual overloading of the other lines. And then if it is a cascading effect, the entire system will go down as well. Okay, another thing is physical damage to infrastructure. So we can basically manipulating the different datas, uh, like generation data or the transmission data. Uh, we can overload certain component of the grid, and that may leads to the failure of that component. Okay, and then further it can lead to the cascading failure. And the same, like the example I have discussed, like I can manipulate the data of one line, and if it is manipulated, the system operator will respond according to that manipulated data, and it may cause overloading in that particular line or some other lines, and because of that overload, the equipment failure will be there, or our traditional protection system will come into picture, and that may basically isolate that like overloaded section, and once it is there, uh, that power flow will go to the some other part of the system, and it may go into cascading failure. Okay, so more difficult to detect and response to the outages, because the reliability is basically can be reduced with the help of the cyber attack, because the attacks are designed in such a way that they are not like we should the system operator should not be able to detect them. Okay, so they are more difficult to detect, and until unless we know what is the like actual fault, or what is the anomaly in the system, it is very difficult to respond to the those outages. Then public safety is another point, so it can disturb the critical infrastructure. Okay, So like power supplies to our hospitals or different emergency services, if this can be hampered, it leads to the public safety issue as well. Okay. Now like economic impact. So economic impact is like very simple. Like if I look at, well, simply like if you look at the a load point of view, if a load is able to manipulate the data on the smart meter and send the falsified data to the system operator, and obviously it will try to reduce the consumption, and in that case it will pay less, but the system will be in loss. So those are like economical impact. Okay. And another is data theft. So it is basically in India so far, we are not worried about like power usage pattern, like how load are basically a consumers uses, what is the consumers uses pattern. But with the data theft, we can able to identify the different pattern of the consumers, grid operation, even the personal customer information can be out in the open. So those are different impacts of the cyber attacks. And this will basically slow down the adoption of the smart grid technology. If lot of attacks are there, people will be afraid and they will basically oppose the adoption of the smart grid technologies. So this will basically end up in the loss of the public confidence, and it in a way like why we are going to the smart grid to improve the system efficiency and all. So it will hamper those efforts. Okay. So how the major cyber physical attacks are basically, or what are the different histories. So I have kept few of the cyber attacks which happened in like chronological order. So in 2003 in Ohio, USA, there was an attack on the power system. So some slammer worm was like penetrated the control system of the nuclear power plant. So it's a one kind of virus, and or malware, I would say. So that has been like some malware was injected into the control system of the nuclear power plant, and the entire display where we are getting all the information of the power plant was off for 5 hours, and they were not able to remove it for 5 hours. So if we are not able to look at what are the different like parameters in the entire system, we cannot operate that particular plant. So this attack was happened in 2003. Okay. Then in 2007 again in USA, some attack was there, and that manipulated a circuit breaker of the diesel generator. Okay. So it was basically some false data was injected in the system, and circuit breaker basically reacted based upon that false data, that and a diesel generator was basically uh, out and then exploded. So that was the impact of the. Then third, if you talk about like in 2012 as well, like in Saudi Arabia, there was an attack. Again, it was a malware attack, and it basically affected the gas network. Okay, so Ras Gas and Aramco are the like the natural gas suppliers, and it affected the generation and delivery of energy. So they affected those like in like gas lines, and because of that the power generation and the delivery is basically affected. uh, in 2015 attack was there in the Ukraine. Okay. Again certain false data was injected uh, for in this particular attack, and it was on the breaker setting of the two or three discoms of the Ukraine. So they attacked the entire communication network and gave a false data information to the circuit breakers settings, and circuit breaker reacted that okay, some basically overload is there, and they isolated those areas. So the breakers basically opened, and that basically lead to a blackout, and affecting 200 more than 200,000 consumers for a few hours. Okay, so those were like history of this major cyber physical attacks in power system. Uh, there are many reports as well, like attack in our mark like system operators in I think Mumbai. SLDC was attacked, but it was denied by the government. So there was they cited that it was some technical issue, but some reports claimed, we don't know whether it is true or false, but that there are some incidents of the cyber attacks in our Indian grid as well. Okay. So far, we are not seeing any major impact. So we can say that our power grid or our system operator is doing a very good job, and that system operator is able to so far shield our Indian power system from the cyber attacks. Okay. So where attacker can attack basically. Okay. So there are basically we have so like our traditional system, we have generation, then transmission, distribution, and consumption load side. So these are like four major basically we can say parts of the physical layer of our power system. So uh, there are basically monitoring, protection, and control layers within each of these four layers. Like we have to monitor, control, and protect the generation system. Same is for transmission. Same is for distribution and consumption. Okay, so then we have a application layer, or I would say, like what are the different applications. So from the generation point of view, we have a prediction and planning of the like generation. So how much is goes basically scheduling as well. So we have to schedule the generator. So that is part of the planning, and we have to predict how much power we can produce at a particular time. Then in real time, we need generation monitoring and control of the entire generation system. Then for transmission, we basically have perform state estimation. So like as I discussed, that lot of meters are being installed, a lot of sensors are being installed in the transmission network. But with the help of like those meter data, we perform state estimation and try to predict what is the existing state of the entire system, like what are the different voltages at angle in the entire network. And based upon that information, estimation information, the transmission monitoring and control is being done. Once if you look at the like distribution system, we have okay at this like generation and transmission level, we also like perform the economic dispatch, and that is based upon the data we are getting from the distribution network, like how much is going to be the demand, and the demand prediction and everything will be available. So it's monitoring, production and control, and it also like forecast the demand. So based upon that, we perform the economic dispatch in between. And if that data is being manipulated, the dispatch will also be manipulated dispatch, and that will leads to the more cost to the entire system. So demand response as well, like like all the consumers basically, they perform the demand response, and if price signals are being affected, it affects the overall distribution monitoring and control, and like microgrid monitoring and control of the entire system. And there are different application layers, like energy trading. So if we can affect those information, the the optimal point will not be received, and whenever we are moving away from the optimality, it's a loss of basically our uh, economical or the social value. Okay, so these are communication links, so they can attack at the multiple places, like all these monitoring, protection, and control devices. These are the certain devices, so attacker can attack those devices. It can attack on the communication link between these like these devices are basically sensing the data and sending it to the our control units, so it can attack in between the communication link. And finally, they can directly attack to the control rooms, and and they can affect the entire application layer as well. Okay, so what causes the major like smart grid vulnerable to cyber attacks? So this we have discussed, there are increased number of IEDs and PMUs, integration of the PMUs, and those devices basically are places where the attacker can attack and manipulate the information. Uh, some third party components are being installed, then they will have different protocols, different security measures, and attacker can get into our system through those third party components in the system. Then smart meters as a point of exposure to the cyber attacks, because they are at the very end at the consumer level, consumer end, and they are more exposed to the cyber attacks. Then industry automation and control system can also be attacked. Okay. Then the lifetime of the power system. So the implicit trust between the traditional power devices are there. The inadequate personal training can affect the cyber grid vulnerable. Okay, so usually, we trust each other, because the traditional learning a traditional knowledge that, okay, this is if some data is transferred from one part device or basically system to another system, we trust that data, and it can manipulate that trust, and cause some cyber attacks and cyber vulnerabilities in the grid. Then the existing manpower is does not have adequate training to identify, or basically, we generally open some emails, and those emails may have some certain malware, and those malwares can affect the entire system. So yes, the person are not trained adequately, so that is one thing. Then different teams background. So all the entire system is so big that there are different teams, different parties are there. Even the private companies are providing different solutions to them. So they have different backgrounds, and in between those basically like communication of different teams, um, attackers can get benefit out of it. If we are using some internet protocols for the communication of the network, basically for the communication of the data, they can basically play there, and attack that particular segment as well. And as we are installing more and more devices, the amount of data is being collected is more, and the attacker can manipulate that data. And we if we do not have sufficient computational facility or the detection mechanisms, it will be very difficult to analyze whether the data we received is manipulated ones or the right one. So that is also issue. Then, if you look out, like increased availability of the technical specifications are there. Some default passwords, if we are using, then it can be easily manipulated. Limited or ineffective network segmentation. Okay. Then, zero-day vulnerabilities, maintenance issues. So, all of these sectors basically cause the cyber system vulnerable. Now, if you look at the phases of attacking, first is reconnaissance. So basically, it will look at the information, like where attack can be done, and just observe the entire system. Okay, so first of all, it will look at that. Okay, what are the different like observe the entire system, what are the loopholes and everything. Once it has been identified certain, then it will scan that entire segment. Okay, then the third step is to gain access to particular segment. Okay, so like, can attacker get the access of this particular segment? Then once the access has been gained, the attacker will try to maintain that access for long time, and then he will basically manipulate the data, he will basically affect the entire system, and he will clear the tracks, so that system operator is not able to identify that whether it is some technical issue or whether it is a cyber attack or some glitch. So it is very difficult, like it will clear the track so that nobody is able to identify them. Okay, so these are the different phases of attacking. So first phase, if you talk about, like, just information gathering phase. Okay, so we will look at, like, what are the entire network, who are the host, and which peoples are involved. Okay, and he will try to attack either directly on the network or on the host. And if it is not possible, he will attack to the people, that if he can get inject some malware through those peoples. Okay, so it's basically social engineering traffic analysis, like which part is used more, and which part is most vulnerable. Okay, so all of these basically relies on social skill and human interaction rather than the technical skill. So, like, if just we are trying to gather the information, so like, we are discussing with the people and try to get some certain information out. So it's all about social skills. Then hackers try to access the same network as you to listen, capture, and all traffic, network traffic. Okay, so they will listen everything, they will observe everything, and capture the information of the entire network traffic. Then, like, scanning. So identify all the hosts connected to the network along with their IP address. Then, what are the different ports? So goes deeper by scanning the ports in order to determine which port is open, and if they can access that particular port. And then service basically moves on to the service scan in order to find out the service or the system running behind the each open port. Okay, so then they will look for the vulnerabilities, like scanning the target for weakness and vulnerabilities, either at like, IP addresses, port addresses, or different services. Okay, so they will look for the vulnerabilities as well. So so basically the hacker gains access to the system, application, and network. At this point, hacker has the information he needs. So the entire information he has gathered. So first of all, he designs the network map, and then he has to decide how to carry out the attack. So he has to optimally design an attack. Okay, and those attacks can have multiple objectives. So we have, different objectives we can have, and based upon those objectives, the attack vector, or what attacks needs to be done, can be different. So he has to decide, like, what attack should be there, and then how to carry out it. Then there are many options for this example, like, denial of service attack, or replay attack, and all of these attacks are there. So this is the part of. Then third part is, like, maintaining the access. Once the hacker has gained the access, he wants to keep that access for the future exploitation and attacks. So, like, he has gained the access, designed the attack, and mm, he has looked a way to identified a way to carry out that attack. But he will still try to gain the access because he has put a lot of effort. So he will try to keep the access for in future exploitation and attack designs. So hacker tries to maintain the access to the target until he finish the attack and he plan to accomplish the target. Okay, so he will try to keep the access for the then clearing tracks is like, no thief wants to get caught, so an intelligent attacker will always clear all the evidence, so that in the later point of time, no one will be able to find out any trace leading to a particular attacker. As well as the clearing tracks will also, like, keep the system in the dark, that how the attack was basically um, created or designed, so that in future, the like, if once it has been identified that, okay, how the attack has been created or designed, the system operator will make some, corrective actions to so that those kind of attacks can never happen in future. So if attacker wants to clear the entire track so that uh, it the entire design process, the entire like what information has been collected, what attack has been injected, how it has been designed. He will try to clear out each and every aspects. Okay, so this will involve modify or correct and corrupting and deleting the values of logs. So there will be excess logs in the system, and there will be some modification logs are there. So he will try to modify or delete those logs, modify the registry values, and uninstalling all the application he used and deleting all the folders he created in the system. Okay, so that he will try to clear the entire modifications which he made to basically carry out a particular attack. So, what are the different types of cyber attacks in the basically? So, in general, these attacks are there. So, not from the power system point of view, but in general, we have these kind of attacks. So, like spoofing is there, jamming attack is there, denial of service is there, eavesdropping, hacking, forging sensor data, phishing attacks, malware attack, and uh, cryptanalysis uh, uh, attacks are there. So these are the different attacks which can be available and are basically defined. So like if we talk about like jamming attack, DOS attack, it's a basically attack on network communication. So the communication is intercepted, then data sniffing, flood services, injecting lot of data, okay, and different applications, so that the attacker can basically um, slow down the system. Failure services, so different services can be made failure. Jamming the wireless communication environment. Okay, so that is those kind of attacks is there. Distorting the communication channel and messages, manipulating everything and all. And replay attack, once certain communication is there, he can keep on basically replaying that kind of information, and the operator will get the same information over and again. So those kind of attacks are there. Then in hacking, cloud system hacking and sensor hacking, so you can hack the entire system or the equipments. Then like you know forging the data. So those are basically like whatever is the data is being transmitted, just change the data and do nothing. So those kind of attacks are there. So fake alerts can be made with the help of the forging the data. False data can be injected. So I can increase or decrease the consumption or production labor power in this forged data injection attack. Data breach and forgery of the identity, those kind of attacks are there. Then in malware and phishing, basically many viruses, trojan, ransomware, spyware, botnets, adware, those things are basically injected. And then cryptanalysis part, man in middle attack. So integral attack, ciphertext attack, dictionary attack. So those are like different categories and types of attacks there. Data spoofing, IP spoofing, DNS spoofing. So those are the different attacks. So okay, and any attack falls into one of the three categories. So one is availability, one is integrity, and another is confidentiality. And generally we call it a CIA triad. Okay, so availability is like making data and information unavailable. So whatever is the data is there or some information is there, we can basically make it unavailable or delete that part. So that is attack on availability. Then integrity attack is like manipulation of the data and information. So some certain data is there. If we can, attacker can manipulate that data. So instead of power system, we can basically change the voltage values. We can change the angle values which has been communicated to the control center. Okay, and manipulate that data. So this is integrity attack. Then and confidentiality is basically just stealing the and confidential information from the system. Okay, so that is confidentiality attack. What are the major cyber attacks? So major attacks are basically on the integrity of the system, and these are basically false data injection attacks. Okay, So these are basically why they are major, because these attacks targets the measurements and control signals, and all the measurement units are basically in power system are out in open, so they are basically easy targets as well. And their communication is also quite out and open, so these measurement units and the control signals are can be basically easily targeted. So those are the main attacks in false data injection attack. Another attack which is quite major in terms of the power system is denial of service attacks. Okay, so that is basically attacks on the communication channel, and we can block the entire information going to a particular control room. So either block or again transmit illegal data packets, like instead of whatever we are expecting, get something else, some other data. So these kind of denial of service, so the data or the service or the information should reach to the control system, control center, and instead of reaching there, it has been stopped. So that is denial of service. And if it has been modified and altered, then it is false data injection attack, FDIA. Okay. So on communication channel, generally the attacks can happen is basically DOS attack. So deny the data packets are unavailability. So you can make the information which is going to the control rooms unavailable. So that those are basically DOS attacks. Then another attack which is possible on communication channel is delay attack. So like let's say certain information should reach there within the time, but it can be delayed, and that basically will leads to the time, then the time synchronization will be needed. And sometimes to control the entire system in real time, we need information of a particular timestamps. So if those information are not coming well in the time, then those attacks are basically delay attack, and they can affect the entire system. Okay, so let's say a relay is there. Okay, and some measured during the fault condition, some information or like voltage currents has been measured from the system or in a section part of the system, and those values has been basically sent to the relay. As a if the measured value is greater than the pickup value, then relay should trip. Okay, so and the relay will send a tip signal to the circuit breaker. If we attack this particular channel from relay to circuit breaker, and either the attack can be DOS attack, this signal is never sent to the circuit breaker. In that case, the section will be faulted all the time, or maybe it has been delayed. So the response will be delayed, and it may leads to the other parts or basically other equipments in the system be under the overload, and the maybe the primary protection does not work. In that case, the secondary protection will come into picture, and that will basically isolate the more or increased more size of the network will be isolated in that particular case. So like whether delay attack or whether it is DOS attack can be there. So another attack can happen at the measured value. So we are measuring certain values, and if we attack those values, relay will never see that some fault has been there. So we can basically attack at the communication between the measured value, and once it has been transmitted to the relay, it like in between either it is can be modified, it can be stopped, it can be delayed. So those kind of attacks are basically there, and in that case our response of the relay to tip that I faulted section in under the fault condition will be either does not happen at all, because we have this control room doesn't even know that if there is a faulted condition, or it may be a delayed response and leads to the more severe fault condition. Okay, so So like measured value is like whatever is the x, and you just insert some delta x value in it, and once it is there, then uh, so let's say certain values there. Let's say some current is being measured, and if that current is more than pickup value, the relay should trip. But it can change that current value by just inserting some error. And let's say if it is negative error, then the measured current will be less. Okay, and in that case, the relay will not trip the circuit breaker. So that is one attack. Then another case is change the existing parameter itself. So like measured value is there, but whatever is the in control section or in the relay part, uh, just increase the pickup value. In that case, even though the fault current is more than the what is the actual pickup value, but if we have changed the pickup value, the relay will again not trip. So attack can happen there as well. So there are users, let's say user one and user two, and they have certain connection. And now let's say man in middle attack is there, like these user one and user two are communicating with each other, but a man in middle attacker is basically acquired that communication channel, and now user one is basically communicating with this attacker, and user 2 is like instead of user 2, the attacker is responding to user 1, and he is basically observing the entire information, so he can gather the information, he can basically mislead the users, and that may lead to the system disruption. So user 1 think that he is communicating with the user 2, but actually he is communicating with the attacker. And same, the user 2 will also think that okay, I am communicating with the another uh, like party or another user of the system, but attacker is there, he is gathering the entire information, and he may be basically injecting some false information to these users. Okay, so like some attack was there. So let's say some worker is there, he analyzed certain data and asked to perform a task. Okay, so in SCADA, some task perform to a particular task has been initiated. SCADA will do that and perform certain task, and that has been basically sent to the power line communication. Now, if some attack is there in the SCADA as well, then instead of task A, task X will be like it will send a signal to perform task X, and then uh, it will also send a signal to the worker that okay, task A is complete, but in actually some other task has been performed. So let's say by looking at some information, it has been asked to isolate or basically operate a particular tie line, and instead of that tie line, some other tie line has been basically operated. Okay, and in that case, the worker will think that okay, this has been completed, but some other topology is there in the system, and that like operator on the computer will think that my network is basically has certain value based upon the tie line switch or the tie line task he has been initiated, but actual system configuration will be different, and whatever is the results he is getting for the entire power system, like well, let's say he's performing optimal power for the dispatch, he will get the different results because the topology is completely different, and then they may lead to the the disruption in the services and the entire system. Okay, so attack against the state estimation. So this is a very common attack as well. So what happens that we have different meters installed. Okay, that those meters basically transmits the entire information with the help of this remote units over the communication network to the control center, and in control center we perform the state estimation, and with the help of the state estimation we basically look at the different sensitivities, and we perform the stability analysis, we perform the contingency analysis, and we also perform like based upon that data like optimal power flow and economic load dispatch and all of those. basically task is being performed after the information from the state estimation. So different kinds of basically either integrity like false data is being injected. So once the false data is being injected either at the meter level or the communication level, the control system will work on the false data, and or some data can be basically stopped. A DOS attack is there, so that data is not even coming to the control system, and without that data we have to perform our all the operational tasks. So this is basically a integrity and availability attack, or a combination of both integrity and availability can also be performed. Okay, so attack can be at the measurement level. Attack can be at measurement collection level. Then attacks can be on the communication network, like from the measurement collection it transmit over the communication network, so it can happen at the communication level. Attacks on the receiving end level in the control room. Okay, so those are the places where attack is possible. So let's say different PMUs are there. Okay, and they follow certain IEEE protocols. Okay, and then if you look at if we, some GPS spoofing attack is there, so attacks on the PMU itself, some attack on the communication network like denial of service, post data injection, delay attack, or man in middle attack, and then it will compromise the PDC, and then and the DOS attack on the further communication, and this data is basically going to the super PDC. So those kind of basically attack positions are there. Now another power system, the topology attack. So some there are two types of attack on the topology as well. So okay, if you have any doubts, again I ask you to just put them in the chat box. Okay, and I will take a 2-minute break just. Yes, so we were discussing about the topology attacks. So generally in distribution network, if I talk about the topology is basically keep on changing. We have different, like certain tie lines. So we usually try to make a radial structure in the distribution network. So we turn on some tie lines and turn off certain tie lines continuously to like reliably transmit the power to the different users, and with the like to maintain the voltages, and sometimes to isolate a particular faulted area, that reconfiguration is is being performed. Okay, so the attacks can be like physically alter the topologies. Okay, and another is cyber topology attack. So here, like physical topology, like a person can go to the substation and operate on the different tie lines, keep making them on and off. So, but those are like physical one. But in cyber topology attack, there can be different. One is like with the help of attack, he can mislead the circuit breaker to either open to close. So if a circuit breaker was open, attack can be there to add the particular line. It can remove the line by making the circuit breaker close to open, and then it can switch the circuit breaker status and change the entire topology. Like certain part is affected continuously. So it's a basically different coordinated topology attacks are there. So if attacker physically disconnect the transmission line, then the topology of the power system is altered, and this attack can be easily detected in the control center by checking the data status of the transmission line. So like if we are looking at the physical topology attack, the control center will know about it. So, thus the attacker will first disconnect the line and the physical system, and simultaneously manipulate the line status via cyber attack, and so that it will not be able to identified or detected in the control center, because the line is being physically removed, as well as the line status is being manipulated in the control center. Instead of just making the physical disconnected line, uh, sometimes attacker can create new fake line outages, which is different from the disconnected line. So like certain outages can be created so that the lines are basically made out, and which are not supposed to be out. Okay, and sometimes the physical network is something else, and it can attack in the manipulate the line status, and the control system or the control room will have different topology as compared to the what we are basically having in real world. So it can be multiple variants can be there. Okay, so if we talk about different attacks, basically, so these are computer science topics, maybe those topics specific PhD. uh, Push, can you like open the chat box? No, some comment I received, but why it is not visible there? Maybe. Just a second. So, yes, but so far I'm not talking about like, the research related points here. It's a basically general information which is needed for the the personals and manpowers in our grid, the system, as well as, the graduating students like PG students should be aware about these, so that when they are going into the field, they should know our basics about this, like what are different attacks and what are their consequences, and like how what are the places are which are vulnerable. Okay, so different types of attacks are there, like forced data injection attacks. So it is to create unsafe frequency excursion. Okay, and the type attack target can be like our AGC, and here by manipulating the power flow measurements or by compromising the physical sensors, data, and the communication link at the control center, and the consequence is disconnecting the customer load or generators, or maybe uh, leading to blackouts, or potentially cause the equipment damage. So these are like, basically what are the like attacks, what can be the objectives, and what are their means and consequences. Man in middle attack is to like block a particular relay, and like either operating a particular relay or not operating a particular relay, malicious opening of the circuit breaker. Okay, so targets are basically the communication protocols. So there are different communication protocols are there. So this IEC 61850 and BOOS and SV protocols are there. So those protocols will be basically attacked, and in these basically they are basically injecting or spoofed data and to the communication network, and the consequence is basically like, let's say if we open a particular line, it can lead to the cascading failure of the entire system. So it can be like either a section of the entire power system is isolated, or it may lead to the complete blackout as well. Okay, so to cause the damage to generator, motor, and transformers, and basically at the like each equipment is basically a target, and it can be achieved by targeting the communication channel or directly hacking to the relays to open or close the circuit breaker, and they will basically functional failure or interruptions are there. Then delay attack, malware attack, pricing attack. So delay attack is like we have delayed certain information, so it will basically uh, all the real time monitoring and like actions will be affected by the delay attack. It can happen between the on the communication network between the like these phase measurement units and uh, like PDCs. So phase data generally we call it collector or concentrator. So on those attack places, and the attack can happen. So by introducing delay between the measurement and coming from different PMUs, and the real-time applications based upon whatever the data PMU data will get affected by it. Uh, it will basically malware injection is to like interrupt the entire system. So it will like the display or the basically the entire control room is not able to function. So those kind of attacks are there. So it can happen like on a communication channel to control center or control command signal. So those has been affected by it, and it will leads to power outage and blackouts, and disturb the entire economy of the countries. Then pricing attacks are basically like they will be there just to get some financial profits. So they can the attack can be on the transactive energy systems, pricing signals, the bid signals, and by manipulating the bids and these price signals, some economic loss will be there to the entire system or a particular attacker or target by the attacker. Okay. So apart from that, like denial of service attack, it can be basically on the SCADA by targeting the substation and the different access points. It can basically goes to like loss of load, loss of information, economic losses, equipment failure or damage. Then data integrity attacks can be done upon like forced transaction on fact devices by just injecting falsified information on the various like loops of the fact devices, that will leads to the oscillations or variations in the voltages. Switching attacks are on the circuit breaker, so either they can basically on or off the circuit breaker, and the consequence will be frequency and voltage instability. Multi-switching attacks on the circuit breaker will be able to uh, like initiate a cascading failure of the entire system. Load alteration attack are basically consumption sector, and the loads can be altered. Like somebody can get financial benefit out of it if he wants to reduce a particular load, and it may basically damage the grid through circuit overflows. Okay, so there are different basically. So what are the possible consequences of the cyber attack if we talk about? So it is basically like disconnection of the. So yes, there are some questions, and I will take them just like before some time. So what are the possible consequences of the cyber attack? So one is like disconnection of the load, shutdown of the generators, disconnection of the transmission lines, and disconnection of transmission lines can lead to the cascading failure of the entire system. So let's say like some critical lines are there which are transmitting huge amount of power, and if we are able to disconnect that, that entire power will redirect to other entire like other lines, and those lines may also be overloaded, and once then the circuit breakers of those lines will operate, and that will leads to the like the entire lines are being basically uh, tripped over time, and it will leads to the cascading failure of the entire system. Loss of frequency control and excess and deficiency in the reactive power support. So these are like different consequences of the cyber attack, and they will affect the transit instability, frequency instability, voltage instability, and different overloads. And finally, like the overall outcomes are basically because of these effects, the equipment will be a failure, a regional outage, or a complete blackout. Then some unintentional islanding can be created, and like financial losses can also be there. One so we have studied basically so far, like we have gone through economic load dispatch, we have gone through optimal power flow. So I have just on the similar problems. One attack is there. One is called a load redistribution attack. It's a just attack on the system operation. So that's why we will look into it. So let's say a certain physical power system is there, and in that particular power system, some certain demand is observed. That okay, this is going to be the demand. Then our control center will either perform economic load dispatch, or it will perform DCOPF to schedule the different generators to meet out this particular demand. In that case, it will give you the schedule of P generation. So this note is like the actual demand, and for that actual demand, what is the actual optimal generation schedule. So this is how our DCOPF, or we can say economic load dispatch, is basically giving the schedule. Now here this like PD node, PG node, and the PL node is also like it is the part of the network. So all the lines are basically well optimized. So in DCOPF we try to like consider the line flow limits, and those lines are not overloaded, and based upon those line flows, like optimal line flow as well, power flow, we are basically creating this particular schedule of the PG node. Okay, so this is like how the system should work. Now if there is a physical power system, and attacker basically gets certain information, and the actual demand is still PD node of the power system, but attacker injects certain false data, and it changes the power demand, and a new power demand will go to the control center. Based upon that, a falsified dispatch will be there. Okay, so and this falsified dispatch in the control room will create a dispatch for a falsified basically demand, and it will that generators will be scheduled in such a way that all the lines are within the limit for this falsified demand, but the actual demand is still same. But so actual demand is the same, and we are basically giving certain some falsified dispatch. That falsified dispatch and actual demand can basically uh, change this power line flow suboptimal. So that line flows can go beyond the threshold, or they will be basically different for the particular system. So this is basically a load redistribution attack. So it's a you can call it a false data injection attack. So we are basically injecting certain data into whatever is the data coming from the physical power system to the control room, and a falsified data is being communicated to the power system. Now, but it is this load redistribution attack is one of its kind. Like it is also a false data injection attack. But this attacker is doing some other analysis as well, that it is not manipulating any generator measurements. So it is not doing anything at the generator level, and all the generators are basically being scheduled from the system operator from the control room with the help of all the economic load dispatch control are like DCOPF or optimal power flow control. Okay, so it is basically manipulating the loads only. So loads are being manipulated, and that too by a very small fraction. So like hardly 5% or 10% deviation is basically created in the load, so that the detection is avoided. Okay, so this is one of the attribute. Another thing is the system operator also knows that okay, at a particular hour certain forecast is there, and the total load is he is aware of that. If the total loads changes, the system operator will suspect that some attack is there, and he will take some corrective actions. But the in this load redistribution attack, what we do is we try to the attacker is basically how can I. So in this basically the attacker manipulates in a load in such a way that the total summation of changes will be equals to zero. So let's say if a certain 5% change is being done to a particular let's say load one, there whatever is the quantity, let's say 10 units has been increased, then in some other load the 10 units will be decreased as well, so the total sum will be zero. So system operator will not see any change in the total system demand. So total system demand will still remain same, but the locations has been modified. So that's why it is called load redistribution. So whatever is the actual load, it has been redistributed, and it has been basically modified. Okay, and so these are certain conditions for that. Then some information or some data basically we have here, like for a modified IEEE 14 bus system, there are some generators at 1, 2, 3, and 6, 8 bus number. Okay, and then we are basically some cost functions are there, and some like power outputs are there, and certain load data is also available at different buses. And we have assumed that all the lines are basically having a rating of 60 megawatt. So and this entire information is available from the mat power which we discussed earlier, like this entire information there. So we are considering total number of 54 meters. So like and each line we are assuming there are 2 meters. One is at sending end, and another is at receiving end. And then we have meters at the generator buses, and then we have meters at the load buses. Okay, so those meters are there. So this is a attack vector. So like like we have sold some load redistribution attack, and at different bus numbers attacker will what the attacker will try to do is like it will increase the bus 2 load by 5.4, and bus 4's load will be increased to 17.21, and then it will reduce the load of bus 3, and the total summation of these, and there is a small change in bus 6 as well, like 0.37. The total summation of these three will be equals to the negative change of the bus 3, so that the overall total demand will remain the same. Okay, so this is change in the load measurements. So uh, and the objective is defined in such a way that it is targeting a particular line. So let's say it is targeting a line number 30, and the line rating is 60 megawatt. And before attack, like after doing this particular attack, the line flow in this line number 3 is becomes 69.57 megawatt. So it is more than the line rating. Okay, so if that happens, then that line will go out. Okay, so this is what basically like different bus numbers are there, and certain attacks has been defined, and this is the impact of load redistribution attack on targeted and non-targeted lines. So this blue line is base case flow, like what are the like different lines and what is the base case flow, and then percent after the attack what are the different flows, and percentage change in the load. So what change is there basically in the load. So to certain loads has been changed, and like if you look at lines, uh, change of their like 173% is there, and the loading of a particular line. So line number 6 has been loaded too much heavy. But if we just look at so we had a line rating of 60 megawatt. Okay, so like all the lines have a fixed capacity of 60 megawatt. So if you can see, line number 1, line number 3, and line number 4 are like operating before the attack on the 60 megawatt or close to 60 megawatt. But if we try to adjust or redistribute the loads, the uh, after attack flows will go high. So like you can see, it has been slightly increased from the 60 megawatt, but line number 3 was our actual target. So the load basically line loading for that particular line is increased to 69 or roughly around 70 megawatt. So in that case, this line will be tripped. Okay, so this line will be tripped, and similarly, like in Ukraine case study, the cyber attacks were complex, and they consist of the these steps. So the prior compromise of the corporate network using a phishing emails with the black energy malware. Okay, so a phishing email was there sent, and once it was opened, certain malware was basically inside the entire system, and that malware was accessing the information and sending it to the attackers. So with the help of that malware, it sees the SCADA control, and the attacker was able to remotely switch the substation on and off. So it disabled and destroyed IT infrastructure component and uninterrupted power supplies, modems, and RTUs, everything. The destruction of the files stored on the servers and workstation with this kill disk malware was also performed. And after that, the denial of service attack on the call centers to deny consumers up to date information on the blackout. So, like consumers were reporting blackouts, but a DOS attack on the call center was also planned in the same attack. And at the end, like emergency power at the utility company's operation center was also switched off. So, like complete blackout was done. So, three distribution system operators were affected. A lot of people were affected out of it. 103 cities and towns were affected by this attack. So, this is the like significance or impact of the cyber attack. So, we should basically distribution operator should focus on these. Roughly around 135 megawatt impact was there. Hundreds of equipments were damaged or basically compromised. uh, 7 substation of 110 kV and 23 substation of 35 kVs were basically compromised, and it took around 4 to 5 or 7 hours to basically the entire outage was there for that much duration. Some parts was restored, but like to recover the entire affected area, it took 7 8 hours. Okay, some field devices were also affected and compromised, and that was during like in the winters, and the temperature at that time in the like in the country was roughly close to 0 degrees centigrade, like between 4 to -8 degrees centigrade. And at that time, if power is being, like not there, it creates a very panic situation in the entire country. So these basically cyber attacks uh, can significantly destroy the entire economy of the country. So is there any doubts before like moving to the consumer privacy part, uh, which is like a different side of the cyber attack? And do you have any doubts from the like cyber security of the power system? So far, we just talked about very fundamentals. I haven't been into like much details or like the mathematics which I usually prefer. If you have any doubts, there is a question that is transactive energy and P2P trading of electricity is technologically viable. So, technologically viable, yes, it's a concept, but adaptation is still, like not um, that much feasible right now, because what happens, like if you are transacting between supplier, so it's a transactive energy is basically in transactive energy as well, different peers communicate with each other. So again, like P2P trading is there, and in P2P trading, what needs to be done is coming up with a, common price, negotiated price, and then fulfilling that particular P2P agreement. Okay, so to involve the demand and like the other side, like instead of the generation, the complete demand side into the system, it will help the entire system. But the issue is uh, the loads are very too much, like very small and nuclear. Okay, so it is very difficult to get certain quantities, are basically like enough quantity to meet out the loads. And in that case, like P2P is far-fetched so far. But from the research point of view, yes, we should work on those options and should look for the like research or methodologies and algorithms to make this technology viable, because it has a potential. It will support the entire system, and it will leads to the a sustainable system. Do you have any doubts so far? So what is the perception about smart meters, if we talk about? So if you read in many articles that talks about uh, privacy issues with the smart meters. So like smart meters are recording. Yes. So like smart meters are, so far, like in this particular workshop we were discussing very fundamentals, and that's why I kept the something new and some interesting topic at the end, so that we were able to build up the fundamentals and finally, try to at least target one potential area where maybe you can work in future. Okay. And we can you can also email me if you have any doubts, and we can collaborate, and those things are always possible. Okay. So we're talking about perception about smart meters. So generally, news articles, we see that there is a possible what can be the defense strategy against any cyber attack. So so far, if we talk about, okay, so the question is, what can be the defense strategy against any cyber attack? So far, what system is doing is basically having a bad data detection mechanisms, and usually it performs state estimation as well, and try to with the whatever is the information available, and from the different measurements, try to build solve the state estimation and see if there is any discrepancy. So like bad data detection is being done by the system operator. So for very fundamental attacks, false data injection attack and all these attacks, it is okay, fine. But as we talked about one attack, in this particular example, load distribution attack, where we were changing the load with a very slight value, not like we are not affecting the load value too much, and that degree of variation is very less. In that case, the bad data detection will not be able to detect the attacks. So if you look at the defense strategy, first of all, you have to understand what are the actions or where the attacks are happening. So from the computer science point of view or the communication network point of view, our protocol should be well protected, and a firewall should be there so that attackers are not able to penetrate a particular firewall. So that is from the computer science point of view, and there are people who are working in that particular segment. But if I talk about from the power system engineer point of view, uh, yes, we can also help in that regard. So attacker is basically gaining the access or the information and then designing a particular attack type. So those attacks are basically evolving day to day, and we cannot detect the evolved attacks with the same method. So we have to basically uh, incorporate or evolve our defense mechanisms as well, multiple um, detection schemes are basically algorithms has to run in parallel to basically identify and detect the cyber attacks. Another thing is use of this AI, artificial intelligence techniques, to basically identify whether the data is being modified or not. So historical data, we have a lot of historical data, and from that basically we can identify whether the attacks are basically uh, there or not. So we can, if we can incorporate both tools of these learning tools like AI ML based tools and our physical algorithms, like working on the physical data, if we can uh, come up with some hybrid approaches, we can and detect those attacks. But from the defense point of view, it is only from the computer science point of view that we should be able to create a robust firewall so that attacker is not able to penetrate our communication layer. Okay. Isn't determining contingency for the FDI and modified protection algorithm helpful? So the thing is, attacks are different, and the attacks are of can have different objectives. The first objective is just to observe the information. So attacker is not doing anything; it is just gathering certain information. So in that case, as a power system engineer, I will not know anything at all whether this like uh, attacker is there and he's observing or basically just gathering the entire information. So that is also attack, but it can be detected from the our computer science or communication science point of view, that whenever some unauthorized access is there, the computer systems create some logs, and if we analyze those logs, and if we with the proper techniques and algorithm we analyze those logs, we we are able to identify that some attacker or a phishing attack was there, and he was just gathering the entire information. Okay, so that is one thing. From power system point of view, will not be able to know until unless an attack has been created. Okay, or basically attack vector is injected. So once the attack vector is injected or false data is injected, some circuit breaker is opened. In that case, we should basically plan that what should be the course of action. So instead of like a defense strategy, power system engineer can always work on the mitigation strategy. Some attack has been there, and in that case what mitigation we can have, how to basically like quickly overcome the attack and come back to the natural state. So yes, there should be some contingency planning for different attacks, and the protection schemes should also be basically updated, and certain randomness can also be created, so that what is actually happening is not known to the attacker, and whatever, let's say if he tries to gain access of certain information and try to create a attack vector, it can be easily identifiable. So yes, the contingency should be basically we should have some contingency planning for attacks as well. Okay, so any doubts so far? Okay, so let's talk about like privacy issues of the smart meter. So as we know that the smart meters are like located in the consumer ends, so they are more exposed. They are basically there for the efficiency of the energy, but the question is, are they secure? Can somebody attack or basically hack my smart meter, and can, once the entire smart home energy management system is let's say assume hacked, he can operate the entire system, he can get the data out of it, and consumption patterns basically. Okay, so who can access my data? These are like big questions. First is like, are these secure? Who can access my data? What does the energy companies see? So yes, like with the smart meter data, they are basically fetching a minute to minute energy consumption, and why the energy companies need that. Okay, so what they can basically observe from that data. Uh, the hackers can spy on the habits. So like based upon my consumption pattern, um, if you read, there are many papers which are working like discussing about like consumption patterns. So if based upon the different consumption patterns, hackers can identify if the house is empty or not, if how many persons are there at particular time, what are the different pattern, like let's say at what time people are going out to the work and what time they are at home, and house will be empty for a particular duration, and so those information can be basically uh, gathered by the hackers. So, is it true that smart meters raise privacy concern? So, I would say yes. Okay. So, then non-intrusive load monitoring is there. So, this is a process that can identify which appliances are running in a household based purely on overall power signal from the home. So as I discussed, there are methods by which we can basically identify that what are the different appliances are being used, and just looking at the energy consumption pattern, overall energy consumption pattern. So like there are 6 or 7 appliances are at the time in use. So the like in the smart meter and beyond, the combined information will be going, but with the help of this non-intrusive load monitoring, and we are basically can be identified that which appliances are being in used. Okay, so this is kind of like average power signal, and the attackers can access it, and attacker can basically decode this average power signal into like consumption pattern of different devices, like whether it is a a furnace, oven, some electric cooking is being done, or some washing machine load, geyser load. So he can basically remove those, like refrigerator is always on, so he can out of this aggregated power signal he can remove the first of all that okay, this kind of consumption pattern will be there for the fish, so he will remove that. Then he will try to identify, and with this particular method we can basically um, disaggregate this overall power signal into the consumption pattern of different devices in our house. So yes, it is there. So now, what is, like, how they might use it? So that is also a question. Like, let's say if somebody knows my pattern, what basically can be known, and what can be basically use of that information. So by disaggregating the total energy uses, attacker could determine which appliances are being used at a given time. Okay, so like electric stoves are the, like furnace is being used, that it means some people are there who are somebody is cooking there, so home is occupied, so they can know whether it is occupied or not. Behavioral patterns can be identified. So let's say some electric kettle is being used. So obviously, like if I'm making make, water, basically hot water, or making some tea, the attacker will infer that someone in house wakes up at a particular time. So at that time, somebody will be awake, mostly in the house. Uh, let's say a light on and off in a particular house, which can give the information of, like the persons will be sleeping or not. Okay, so those are like behavioral pattern. Presence and absence. So it is like some most uh, dominate aspects of that, like attacker could determine whether the house is vacant or not, and then basically can theft can be uh, performed, and like they can. So for example, there is no energy usage during a period when the house is usually occupied. It could suggest that like whether house is vacant or not. Okay. Specific device information can also be extracted from the overall energy information. So some devices have unique energy pattern. Like our washing machine has a unique, microwave ovens have a unique pattern. So attackers might be able to identify the presence of a specific device, which could reveal the lifestyle or economic status. Like what is the economic status of a particular household, and based upon that they can judge how much money you have. Okay, so it's again one of the way. Medical equipments, if somebody is using certain medical equipments, it can be identified. Okay, and that information can be used in public to maybe harassment, and like for other purposes. So if an attacker identifies power uses from a specific medical devices, like home dialysis machine or oxygen concentrator, they might infer that someone in household has a particular medical condition, and that information can be used to basically uh, get money out of them, like whether otherwise they will disclose those medical conditions. Sometimes we want to hide that information. Once they had identified these people, the hackers could submit fraudulent claims on their behalf to the insurance company and can make the profit out of it. Okay, so that is also possible. Like just they are just observing the information. They have not done any attack on the household, but they can basically get claims from the our insurance company and make profit out of it. Okay, so while we worry about the complex issues like national security, consumer privacy, etc., but guess what happens right under our nose? So let's say this is quite common, I think. Okay, so ways to commit theft. So earlier, one diagram I have shown that was like earlier ways to commit theft, but under cyber environment, it is more sophisticated and I can say easier as well to commit the theft. So physical attack is like more common in old days and underdeveloped region where we basically hang some wires on the directly like distribution lines and getting power free of cost. In cyber attacks, what we can do is we can attack our smart meter and then put false information about the usage. Okay, so this is the way, like without doing just over the communication network, just attack the cyber smart meter, and the false information will be going to the distribution company, and based upon that, uh, the consumption can be reduced. Okay, as compared to what is actual consumption, and the billing can be basically altered. So whatever normally finds an achievable and convenient stealing method based upon the current system setup. Okay, so these are the ways to commit theft. Uh, Consumption attacks. So like we can modify the different consumption. Pricing attacks. So if you are talking about like complete smart grid, then the demand response will also be part of it, and we can basically uh, change the prices on which the basically we are making the consumption. So load profiles can be shifted. Okay, so let's say some load profiles are there, some high price during time, so this part has been shifted to other entire information, and then we will be paying very less. Okay, so reduction in the load. So whatever is the actual consumption, we can reduce the loads as well. So these are basically different attacks. Navigation from cyber threats to cyber security. So cyber security objectives is like confidentiality, integrity, and availability triad is there. So objectives or is the confidentiality, integrity, and availability, and usually like we look at the availability aspect more than integrity and then confidentiality in the terms of power. Then if we look at the availability is the like most important security objective of the power system reliability, whether the we are able to supply power or not. Okay, and then time latency associated with the availability can also vary, that how much for how much time we were able to stop the services. So usually, like less than 5 milliseconds for protective relay. Like we the protective relays works within like 4 or 5 milliseconds. So if availability is denied for this much time, it can affect the operation of those protection systems. Sub seconds for transmission wide area situational awareness monitoring. So yes, time latency is there with the availability. Like even if you stop certain signal or certain data for a very like just a seconds, then it will affect the entire operation. So seconds for substation and feeder SCADA data, minutes for monitoring non-critical equipments and some market price information, and for hours per day, like like for metering point of view, it's not like every second data is being fed to the distribution company. Generally, they have like 5 minutes or 10 minutes interval in which they basically read the take the meter readings. So those are the different time settings with the different sectors and different like objectives are controlled in the system. So the availability attack is basically very crucial, and even if it is for seconds or milliseconds, depending upon where the attack is there, where the attack is created or basically targeted, it can create very serious issues. Okay, then integrity, if we talk about, so includes like data has not been modified without any authorization. Secure source of the data is authorized, then timestamp associated with the data is known and authenticated. So this is how we can basically obtain this. Then confidentiality, if I talk about, so confidential is the least critical for the power system reliability point of view. So like from the system operator point of view, the confidentiality, like consumption pattern and all, are least critical, because first of all we have to make sure that the entire system is up and running. That is the very first objective. Okay, so but this becomes important, and from the consumer or customer point of view. Okay, so particularly with increasing availability of the customer information online, so the privacy is very much basically uh, uh, issue from the customer point of view, but from the system operator point of view, this has the least critical point. So okay, if we look at like uh, privacy, we may talk about in depth as well, but let's first of all securing smart grid. So as there was a question that can can we devise some defense strategies against cyber attacks. So cyber attacks are not like one kind of attack. They are basically very different types of attacks are there, and they are also the attacks are also being evolving over time. Okay, like in recently we have published a work upon like how we can design a stealthy cyber attack. Okay, so load redistribution attack we designed, and how we can basically make it stealthy and not like our existing bad data detection will not be able to detect it. So yes, we are working on it. So attackers are also maybe working on it, and they can basically come up with the more sophisticated attack. So we can say there is no single solution. Like one strategy is there, and you can adopt that strategy. So one solution will not be able to cater all the issues. So the security to be applied in multiple layers, and each layer provides a different kind of protection. So a defense should be provided in depth at each and every layer and every part of the communication network. Uh, okay, so defense in depth, if we talk about, so we have different data antiviruses, so operating systems, patch, okay, antiviruses. So different segments are there, so different components are there, and then a system is there. So then further, if you look at like different peoples are involved. Okay, so these are like different ecosystem is there based upon that. And so in system we have different network and protection schemes and all. Then another part is like policies and procedures. So we have to work on the policies and procedures on like decisions and operate and respond and recovery kind of segments. So if we look at like what are the strategies, so secure the first of all pre-attack is like secure architect should be there. We have to secure the communication, we have to access the controls, patch management and security by design should be provided. Under attack, the system operator should have some anomaly detection methods, okay, by which he can basically identify if there is a attack or not. From the like logs should be identified whether some unauthorized access was there or not. System health monitoring should be done continuously, whether it, everything is as per the norms. And then mitigation of the attack. Post attack is what should be the response of the system, how we can make it more resilient in the future, and continuously improve the our basically under attack and post attack responses. So like we have to learn with each and every attack, and basically improve our response continuously. Otherwise, like in computers and mobiles, we usually get updates at all the time. So those updates are basically they are learning from whatever is the basically um, negative points, or I would say, like, maybe some attacks are there and they are providing from the security updates if are there. So a lot of attackers are trying to get access in the system. So the companies are like these operating systems, basically they send regular security updates so that your devices will be protected for against the updated attack profiles, like like, so attacks are continuously evolving. So we our response and mitigation strategies should also be evolving with like every time. Okay, so it's like learning from the whatever is the attacks, and then continuously improve the entire system. So this should be the strategy. What are the different challenges? So the increasing sophistication of the cyber threats are there. So cyber threats are basically increasing day by day, and in numbers as well as in the like complexity as well. So it is very difficult to identify, mitigate, and respond to those threats. The power grids are very complex and very interconnected systems, so those are also poses some challenges in the like securing the system. So far there is very insufficient investment in the cybersecurity, so yes, we have to invest more in the cybersecurity. Lack of protocols and the standard of SOPs for in case of the cyber attack, and from the cybersecurity point of view. Then lack of awareness and training among the employees. Okay, so the labor are basically manpower, our personals from the state utilities and like grid operations. They should be trained regularly for the these increasing sophisticated cyber threats, and the skilled labor in terms of cyber security basically are not available, are very limited persons are basically available. So we should increase our manpower are basically personals. So difficulty in maintaining cyber security across the geographically dispersed infrastructure. So it's not like in one building we have to secure. The power grid is basically everywhere. So it's very difficult to maintain the cyber security in the entire system. What are the different guidelines in India if we talk about? So we have certain guidelines about creating the cybersecurity awareness, then creating a cyber secure ecosystem, cyber assurance framework, then strengthening the regulatory frameworks, like what are the different rules. So yes, we are working on it. Creating mechanism for security threats, early warning, vulnerability management, and response to the security threats. So basically, these are some guidelines are there on those factors. Then apart from that, securing remote operational and services, protection and resilience of the critical infrastructure. So then reducing cyber supply chain risk, promotion of the research and development in cyber security. So they are working on that as well, government. And then human resource development in the domain of the cyber security. And in this line, basically, like the human resource development in the domain of the cyber security, we are organizing a workshop, I think on 4th of February, for the our Rajasthan state personals from the transmission company, and like around 20 or 30 personals will be here in MNIT, and we will basically impart whatever is the knowledge we have about cybersecurity, and maybe collaborate with them and share some knowledge, so that as a academia we can basically create more algorithms and solutions which can be used by our uh, utilities. So just an extra information about that. So this is it, like about the privacy related issues and what we can do. If you have any doubts, please ask. Otherwise, then I will move to further. So I have something about cyber auditing as well. I don't know whether I should talk about it or not, but yes, I'm open to the questions. Please ask them. Anyone? So just to give you some food for your thoughts. Okay, thank you. What are the standards and protocols in RPS restructured power system? So there are different standards available in like in terms of cyber security. There are different protocols as well, and different segments like OT security and about all of these. There are a lot of protocols and standards are there. I can share some reference material with you if Dr. Suman. I can share it with you, and but like covering is very difficult here because we are more focused about the system operation aspects of the uh, electrical power system, and just quick info like glance about the cyber security I wanted to cover. So anyone, if you have any more doubts, please ask. You can put your doubts. And are smart meters performing data encryption before transmitting? To be very honest, uh, so far I don't think so. Okay, but yes, they are using secure communication protocols so that the data which is being transmitted is secure. But I'm not certain that some encryption is there or not. I'm very much certain that they are using like secure protocols and like in, in different utilities they have purchased cloud as a data like for data storage. They have cloud services and those smart meters are basically collecting the data and storing it on the cloud. And to best of my knowledge, the utilities are only utilizing these data or smart meter data to only for billing purpose. But like if some of you wants to like do some research or some UG or PG projects, you can ask the students to work on the different data analytics of the smart meters. Smart meter application in any UG lab of electrical engineering. Yes. So if okay, one thing is we cannot change our entire curriculum to just pinpointed outcome. So like electrical engineering basically caters a wide spectrum. So we should have and I like some experimentation on the smart meters, so that the students should be able to uh, they should be familiar with the like how smart meter works, what are the different measurements, how it measures everything, how it communicates everything. So those kind of systems should be there in our UG labs, so that if uh, some of them are working on smart meters, they should be familiar with it. Okay. So any further questions? So many of you are, I think, in early stage of your PhD. So I can recommend you, like look at, like if you are working in smart meter. So these smart meters are acquiring a lot of data, and this data is there on the clouds, or this data is there with the utility companies, and they are only using it for, like a remote turn on and off the supply of the houses, and beyond that only for the billing purpose. But this data can be used, can have ample application. So you can work on, like smart meter data analytics. So a lot of data is available, so you can work on big data analytics. Those are the, like few directions in which you can basically work on. um, in meanwhile, if you have any more doubts, please put it in the chat box. Okay. And so smart meter data analytics, what are the application of the smart meter data based upon, if you just search about these, you will see a lot of literature available on it, and you can basically work towards it and customize it to our Indian sector, so that we get better solutions. Apart from that, like privacy, some interesting, I want to share my thoughts. I may be right, I may be wrong. So we are using, like these social media sites, right? I think the Facebook is there, Instagram is there. We are using YouTube as well, right? So they collect our data, okay, and based upon that data, our data, they basically provide us the ads, and these advertisements, by showing those advertisements, they are making money. So this is, like one very straightforward, there are multiple uses as well, like they are selling our data to the other companies as well, but let's not go into that part. And just from one company point of view, let's say Facebook is there, and based upon our data, search history, engagement time on particular post, they have certain algorithms, and they show us the advertisements, and they make money out of it. So they have lot of users, and based upon those users, they can basically, I can divide that how much is my data post. I can just divide by number of users. That is also very brute force. It is not exactly that much simple, but yes, let's say this much some cost will come. And let's say as a user, if I'm ready to pay that much cost, then they should not store my data. So I can say that is the cost of privacy. So same thing can be done, or can have in our power system as well, like in smart meters. There are a lot of we discussed, like there are a lot of devices, and for those devices we are basically having a consumption pattern, and from that consumption pattern, hackers can identify a lot of information, and we discussed about those information, that okay, and they can know which appliances are being used, whether you are there or not, for if some medical conditions are there, some medical appliances are being used or not. So these are like few cases. So there is what can we can do is, like we can ask for the privacy, and some privacy settings can be incorporated in the like smart meters. And whatever is my consumption, if I'm able to blur that consumption, then it will be very difficult for the attackers or hackers to know the entire information. Okay. But if I blur, or basically modify, or I would say add as some noise in the consumption pattern, then it will be very difficult for distribution company as well to like for the billing and other like load forecasting applications point of view. So we can develop certain algorithms to first of all like enable privacy for the like users, like how we can achieve it without affecting the overall economics of the system, and so that the attackers are not able to basically mm, get the information or insights about our behavioral pattern or consumption pattern and occupancy and all. Okay, so that can also be one of the research areas on which you guys can work on. Another thing is just like in the example which I gave you about like the data cost of the data from the Facebook point of view. Similar can be can be apply similarly here as well. Like suppose if I'm opting for the privacy uh, in an electric power system, then what should be the cost of privacy? So if we are opting for the privacy, we are altering our consumption pattern. If the consumption pattern is being altered, then the cost faced are basically like that uh, will be reflected in the optimal social value of the entire system. And can we develop some algorithms to calculate or basically quantify that social value? And if we are able to quantify that social value, we can basically calculate the cost of privacy in a smart system as well. So those are a few thoughts. uh, Meanwhile, I think we should stop our session today on this particular part as well. Let me see if we can have definition of the audit, need of audit. Let's not go into audit and API. We can talk about these later on. And these are some of the results for which we basically that example we discussed. So some numerical results we have basically identified. Let me just show you like one significant part here. So this on x-axis you can see variation in the load deviation. So we are changing the load by certain percentage. So let's say like by 10%, 15%, 20%. And then you can see on y-axis there is a line loading after the attack. So once you change the basically deviate the load, so like after you can see like after changing it to 40% deviation in the loads, um, you it will be basically that further change in line overloading is not there. So like we the our objective was to overload the lines, but after certain variation like 40% deviation in the load, the line loading is not that much significant, so it gets saturated. Okay. Similarly, like if you look percentage overloading, so you can see that with 10% deviation to a particular critical line, you are able to get a 8.3% higher loading. And generally what we like relay settings we keep up to like 15% or something like the relay pickup. So like if a line is being overloaded by 15% more, then relay will trip. So generally that threshold comes around resources are basically deviation in the load factor of around 20%. So if 20% deviation is allowed, then we can go beyond basically 60 15% percent relay pickup, and it is roughly around 100 and 116.17 um, higher basically as compared to the 60 megawatt. So that's why this 69.70 megawatt as compared to the 60 megawatt. So after that the relay will always trip. So this we can say like below this is the non-critical region. So like if the load variation is below 20%, it will not basically create the cascading effect or line loading. But if the variations are more than 20%, then we can see that it's a critical loading region. And in this case, basically the relay line will have more than 115% of the actual loading, and it will trip. And if it is trip, it will leads to the cascading failure. So, like, this is how we can basically analyze it. And for a different test system, it will be different. It's not always like, 20% variation is true for the all systems. But a system operator can basically, or we can do some analysis, analytics, and find out how much deviation is fine. And based upon that, we can identify that basically that how much error can be considered from the state estimation or bad data detection. Okay, so what should be the tolerance values we should keep for that? Then number of resources, like, attacker also has to realize these load redistribution attack. It has to attack multiple loads, so that it will increase the one load's consumption, and it will decrease another load's consumption. So it has to attack multiple loads, and to hide that, it has also have to attack multiple lines meter. So those number of meters I am considered as a number of resources. So usually, like, roughly around 15 or 16 is basically the critical number of resources it need to get this particular attack realized. If the resources, let's say, like, if it simultaneously attack 10 resources, it will not be able to get a significant overloading in the line, and the objective of the attack attacker will go away. But again, if you increase, if you have too many resources, still the significant variation will not come after particular region. So we can say it's basically like in resource sensitive critical loading region, where the significance is gone away. So, like, 30 resources are enough to get a very much deviation. And these are basically, like, again, like with this particular, like, what are the different load deviations, and given in the terms of percentage. So from the attacker point of view, and from the identification point of view, so whatever that results particular test case for IT14 bus system, uh, they are not like accurately identify the anomalies consumption due to the complexity of the data and other factors which influence the power usage. Okay, the training based methods remain unsuccessful in detecting more advanced attacks than that are not available in training sets, which will directly affect the overall detection performance. And usually, like, most of the solutions in the literature are built using the latest machine learning based methods, but these methods require high performance computational resources, and therefore they, like, slow down the commercialization of these solutions. So we have to look for the methods which can basically easily detect these kind of attacks. Apart from that, one very interesting thing is, like, electricity theft is also there from the load and side, and manipulation of the distributed generation to misreport their electricity injection into grid reported in few papers. So you can work on, like, the economic aspects as well, from the market point of view, that like reduction in the consumption pattern from the load side, or manipulation of the generation output from the generator side, just to get some financial benefits. So there are many papers about that as well. uh, that's it, I think. Let's not go into that. Yeah, what are the, like, different difficulties and challenges? So this AMI infrastructure is not fully implemented, and no precise definition of the anomalous power consumption. So there is no, like, if some deviation is there, you cannot define it whether it is deviation or actual consumption. The data sets are not labeled. So, like, we have very historical data available with us with the utilities, but it is not labeled. Unbalanced data sets could result into suboptimal performance. No standard evaluation criteria for evaluating the performance of existing solutions. Okay, privacy issues are there with the smart meters, and like these ICT devices, and real-time implementation of the detection schemes are still challenging, very challenging, because sometimes it takes a lot of time, and these are needed as well. Like they are needed very much. And if you are working on something, any algorithm, you have to provide that that a particular algorithm is scalable, it has a certain speed, and it respects the privacy of the users. So these are the factors we have to basically work on. So to basically working on certain algorithm for the either attack point of view or defense point of view or mitigation point of view, uh, we have to look whether the proposed algorithm is scalable to large systems. It should be, it should have very good speed, so that that it can be implemented in very fast time, and it should respect the privacy of the users as well. So I think this is it from my side. And if you have any doubts about this, otherwise we will, I think, end our today's session, and we will resume around at 2. Just to again inform you that the quiz is, like earlier timetable I mentioned quiz at 2, but it will be tomorrow. It will be available for the entire day. You will again get 30 or 40 minutes. So that will be enough. Okay. And once you are like started the quiz, I recommend you complete it, because the timer will be on. Okay. So we will have tomorrow, and that's all, I think. No more questions. So we should stop the meeting now. Okay. Thank you.